Yeah, welcome to my talk about database benchmarking, an unexpected journey, maybe some similarities to some movies. I have no license, please don't make any pictures of it. Good to see that so many people are here after this lunch, or maybe this topic is so boring that you want to have a sleep after the lunch, I don't know. We'll see. So who I am? I'm Dirk Krautschick. I'm a solution architect with Aiven. Almost short of a year. I do databases for now 18 years as a DBA, as a trainer, as a sales engineer, now as a solution architect. Basically, a lot of titles, but almost the same everywhere. I have a dark history with Oracle, and I transitioned a little bit to Postgres, so I'm keeping my Oracle know-how as fresh as possible for migrations, but with Aiven, I'm doing mainly Postgres and also Kafka, ClickHouse, OpenSearch, because we are offering this, but my main topic is Postgres. Some private stuff, if you want to have an icebreaker talking to me outside or with a beer or later or something. And short disclaimer, I'm absolutely not a database benchmark guru. This talk is about a journey I had in the past. I will explain how it happens. And everything what I'm showing here is unexceptional open source, so I don't do any commercial stuff. I don't want to do any advertising about Aiven, but to explain the journey, I will do something what I not always do with talks. I explain a little bit what Aiven is doing, so that I will start with. So just briefly to understand why I have to do what I had to do with benchmarking in this case. So Aiven is a cloud provider, a platform provider, but we are not our own cloud. So we are basically providing several open source services, which we are deploying kind of on a virtual machine on the cloud vendor of your choice. So that could be AWS, Google Cloud, Oracle Cloud, whatsoever. And you see that this kind of situation will lead me to the benchmarking task I got. So if you are interested in some of these services and want to know more about Aiven, what Aiven is doing, you can ask me anytime, but I want to keep it as short as possible here to understand why I'm doing what I'm showing you later. So basically, we are talking about Postgres, and Postgres we deploy on several cloud providers, and that is the comparison idea here. So the request, what was the beginning of all this, right? With Aiven, me as the Postgres guy at Aiven got a question by the product management, can you do a performance comparison with everywhere, with some t-shirt sizes, so the plans we are offering with several cores and RAM and storage and everything, on all major cloud vendors. So basically starting with AWS, GCP, Azure, and Oracle Cloud. So, and do it basically with, let's say, the last 3 versions, 15, 16, 17. And compare it also with the hyperscaler offerings, like RDS at Amazon, Flex Server, the Cloud SQL part, so the so-called Postgres variant of this. And of course, when we are doing this, please jump on what is about Aurora, what is about this AlloyDB and everything, the Google offering for Postgres and so on. Just do everything, right? So, yeah. Little ask, right? It's not my daily business. So it's just doing a sideway task during my, so it was kind of a beginning of a long journey. So first, what does performance mean? So what do they want, right? So what should I compare here? So that is the first question I had in my mind. So, and how I would be able to measure this performance or whatsoever kind of sustainable and reproducible. That is the first question that came up in my mind. And the most important question is, what workload? So what do I need to test? So is it something like just creating a table and making some insert selects and so on? I don't know. So I was really open-minded to everything. After those thoughts I have, I started my career a long time ago as an electrician. And I remembered my former, in my apprenticeship, my former, what was it in Germany, is Meister, who taught me everything about this. He unfortunately passed away for a long time. He was always saying, like, in Germany, it's a little funny to say, wer misst, misst, misst. It's translated to who measures, always measuring manure. So garbage. Like so the idea is, if you, from an electrician side, if you start to measure, you always have errors, mistakes, or some disturbances in it. So that was something what came in my mind in the past. So I like to put this quote in front of it. So always think about this. If you start doing comparison, measurings, and so on, always question yourself if that makes sense or not. So my first idea was, because I did a lot of performance-related talks in the past, maybe I can just use this and making kind of a performance analysis as a comparison part. So doing some workload and just measure the performance behavior of the database and compare it. So I had a talk, I used, I'm a big fan of PG Profile, the extension. If you want to watch a talk about this, there's a link on PG Day Paris, I guess. And that was my first idea. But again, my problem was here, what kind of workload? So what is the significant amount of tables or workload or anything? What kind of statements should I run? So that was my challenge in the past. So what do we want? Do we want absolute results? Or do we just want to compare, like this database on this cloud vendor, this database on that cloud vendor? And what kind of metrics do we have? Do we want to have latencies, or do we want to have how fast the query is running, whatsoever? And what is the load? Do we have a specific use case? Do we have maybe some specific application which we can use? But that would be my preferred way. So if you are some kind of a developer having an application and you can actually create some kind of a script which represents the behavior of your application, and you can measure it, that would be the gold standard, in my opinion. Because that is what you are interested in. But I don't have something, so I need some generic stuff. Okay, who in this room already used pgbench? So good, not so much as expected. And who of those people who already used it kind of a real benchmark situation, not only creating some load on the database? Okay, it's less people. It's interesting. So who have heard of this before? Just pgbench, heard that is existing anyway? Well, not that much. So pgbench is a nice little tool delivered with Postgres. It was in the, I hope this is right, I wasn't sure about this, ask in the chat for this, but it was in the config package since version 7, and it is delivered with Postgres itself since version 8.2. So when you look in the bin folder, you will see a tool pgbench. And pgbench is actually the first choice if you want to create some workload on the database. I honestly only used it, that is the reason why I asked this question. Before I started this journey, I just used it for creating some action in the database. So I didn't care about any results. I just want to test something. I want to see some things going on the database. That was the reason I used pgbench before that journey. So what does pgbench? What is pgbench actually? So pgbench is actually a real nice little benchmark tool. So it will create a schema, which is a so-called TPCB sort of base scenario. So that is the schema here. You can create it. It's 4 tables with kind of account, a history, tellers, branches. So kind of a shop-like thing, right? So pretty classic example schema, and with this amount of rows. So and TCPB, what this means, well, I will explain later. So and it will in the default, it will does 5 select, update, and insert commands per transaction. So that is kind of the idea what pgbench is doing. So in these 4 tables, with this amount of rows, what you can see here. So with some example data. And this amount of rows is the scale factor 1. So you can scale it up. I will explain it later. So that is actually what you will get if you start or initialize a pgbench. So a quick start. So if you want to install it, you know, it's quite easy. Everyone should have installed Postgres somewhere. So if not, do it, right? So pgbench is just there. So no installation necessary. That's the fun part here. So, and pgbench is, without any special needs, is really easy. So to create the schema, to create the workload actually, or not the workload, so the basic of the workload, the schema, the tables, the content, you just start pgbench -i. And of course, you can add some parameters. And this is also something I wasn't aware of, that you can actually activate or deactivate foreign keys. So you can create the schema like with relations between the tables, or you can scale it up. So if you have seen the number of rows, if you just put the scale factor kind of 10, then you will get 10 times this amount of rows. So you can really create large databases to see how the behavior changes when you are testing it. And that was really new to me. You can actually activate partitioning as well. That was really interesting. I figured it out literally last week. Was just researching, preparing the talk, putting some details in it, and I recognized in documentation, oh, you can activate partitioning. That's funny. I tried it, and then I was checking. In the documentation you can switch between the versions, and I was expecting that it's something new, but no, it wasn't. So that is, documentation reading does make sense sometimes. So it's really funny if you want to have special cases with partitioning. And there are way more parameters, so we can figure it out. So it's really flexible, even when it's just a tool delivered with Postgres at all. So if you fire it up, of course, this is when you fire it up like this, you expect all connection parameters as default. If you're using PSQL, you know the same. If you have something in database somewhere with a host name or IP and a port and somewhere else, username, password, it's the same like using pSQL whatsoever. So if you can add, here it's just there, right? So you can just connect, it's a local database, local host, port 5432, and so on. So that you have to add, of course. And then you can run the benchmark, just pgbench. That's it, per default, of course. So then it's quite quick, make a little bit load, and that's it. Of course, that does not make sense at all. You can now add some parameters, and you can not fine-tuning, more vary the benchmark run. So you can decide either you run a specific amount of time, that you specify the time, maybe 300 seconds, 5 minutes, or an hour, or whatsoever. Or you can also specify the amount of transactions. So if you want to measure the time spent for, let's say, 100,000 transactions. That is the both first approaches you do. And I prefer the time, and then I will see how many transactions will happen. So that's my preferred way, but it's up to you. It's the same. If you need it for comparison, it doesn't matter. So you will see it. And then you can specify the amount of clients. So then pgbench will simulate several clients making the traffic on the database. So if you don't define anything, it will basically one client doing this traffic script, and that's it. If you define, let's say, 10 clients, it will start up 10 different clients, 10 sessions doing this action on the database. Then you can define also threads if you want to challenge multi-CPU, multi-core systems a bit, and you can also add custom scripts. I never used this, to be honest, but there's a lot of flexibility in pgbench as well. So that's basically pgbench. It's quite easy. So that is an example script. This is let's say an easy version of what I created then. I created a large script running on all cloud vendors, serialized the benchmarks. So I defined a scale factor, a client count, and everything, and then you can easily put it in a log file, and then I used this as to compare the results. Just for you and having an example, I guess you will get the slides. I don't know where yet, but I will provide it somewhere. So if you're interested, you can always contact me, and I can send you also kind of script snippets or something like this. And then you will get the results. So if you are, that's basically the output for the init. So you will see it's dropping the tables if they are already existing. Then it will create the tables, it will generate the data, it does some vacuuming, and then creating indexes. You can disable it as well. You can also disable the vacuum. You can do everything that is. And then you will get some timings. And also this timings you can use for comparison. So that is also kind of useful information. So even when, especially when you're starting to play around with large-scale databases. So if you're making a scale factor from 1,000 or something like this, then it's interesting to see how this behavior is different between several databases or cloud vendors in my case here or something like this. And then you can run the PG bench. So here it's an easy one. Here you see it's a built-in TPCB sort of benchmark. And you see the scaling factor, you see the number of threads and clients and everything, and then you get some initial information about the connection latency and so on. But most important here is the result, like the transactions per second. So that is what I always using for my final comparison. So that is the actual work, what the database has done, what was the reached result for me, right? So if you're doing that on several databases, I compare this. That is my key metric in my test. You will see some broke down results, but I usually don't care. I'm just looking for the TPS, transaction per second. I can show it shortly. Maybe I think the timing is fine. It's the first time I give the talk. So I've prepared a little demo. So let's just create a PG bench, -E, -S10. Then we create some workload. I hope that will work. See, even then it's quite fast. I have here a little activity viewer, so if you can see that it's finally something happens. So that you have seen before in the examples, quite easy, right? So, and now I start a PG bench run, maybe a few minutes, or 1 minute or whatever, PG bench. And let's just choose 5 clients. Then you can see down here that it will really go with 5 sessions. Large T, I guess, 60, let's say. So, and you see down here, it will start doing stuff, right? I think you can also see the queries if I zoom out. Yeah. You see, it's just doing some select updates and whatsoever, right? So that is actually what's going to happen now. So for 60 seconds, it's hammering around on the database, and that's it. I hope you can see it. Yeah, I guess so. So not much special, right? So it will go for 60 seconds, and you will get the results up here, and easy going. So yeah, okay, let's go to the slides, or back to the slides, I guess, and you see the results here. It's still basically getting the results like you see here. So, okay, that is PG bench. Quite easy, it's just there, right? That is a good thing. So you don't have to care about any additional tooling. And I think that you can. My first run was based on PG bench, so it's not like you can say that it's not. It's often underestimated, this tool, right? So you can reach out a good result set. You can compare this. You have everything you need in the first place to at least create some serious benchmark. So it's not like a toy what you just have. It's really helpful for this. So, and of course, I cannot mention it enough. There are many configuration parts you maybe don't have in mind. If you look in the documentation, you can do a lot of different scenarios with vacuum, without indexing, doing some foreign keys play arounds, or maybe also this custom script way is also kind of helpful if you need this. So I would recommend to have a look. If you want to do some performance comparisons, it's quite straightforward and the learning curve is quite high. So the problem is, of course, it's just a little command line tool. There's no fancy stuff around this. And of course, the utilization is difficult because you just get this log output. and then you have to put it somewhere. It's not like, if you want to have nice graphs or something, you have to put it in some spreadsheet and create the diagrams and everything. That's, of course, not there. It's the effort you have to do, but yeah, that's it. The problem about pgbench is, what if you have some specific workload you want to use here? For me, for instance, it's most the important part is what about this kind. TCPB is an OLTP classic workload. So what is about more analytic-like things, right? If you want to compare different things. And of course, if you want to compare other database engines, that is, of course, Postgres only. What is about if you want to check a workload against MySQL? Or worse, Oracle, I don't know, right? And yeah, but first, the TPC part. So a little bit of history about the whys, else of the benchmarking. I found this funny. Benchmarking is now exactly 20 years old, 40 years old, sorry. So there was a first, at least well, that was the oldest thing I found, the first approach about database benchmarking from Jim Gray. It was kind of an essay, which is called about the debit-credit approach. You can download it. There's a version of this essay. You can read it if you want. It's quite academic and really old. And, but that was the first database benchmarking approach. And short after this, a few years after this, there was that is the wise elders, right? The Transaction Processing Performance Council. That is this TPC thing, what I'm always mentioning here. That was founded. And you see pgbench, and also pgbench included in Postgres, and even HammerDB, what I'm talking about later a little bit, is quite a lot of years later. So what is the TPC now? So the Transaction Processing Performance Council, last time I say it like this, is the TPC is a non-profit corporation existing, like I mentioned, 1988. And they, the task they had, it was kind of the idea of creating a really organized industry standards for benchmarking. I don't want to dig too much deeper in this area. There are good talks out there from PGConf EU, I guess, from Mark Wong, which you can check out. He's going more deeper in TPC at all. But what I want to give you here is where this TPC-like workloads came from. So TPC is doing own comparisons, and you can use it for research, of course, and everything. But it's a lot of stuff which you have to pay for, or if you want to have commercial comparisons and so on, then there's cost involved. So, but at least the examples from them, like the TPCA was basically this debit-credit thing approach from the essay from Jim Gray, and later on there was a kind of a more database-focused version of this. That is this TPC thing. So I marked it red because you know what pgbench is using is a similar workload like this. So this 34 years old idea of doing database benchmarks. If you just get an impression how old this stuff is. And after this, the TPC the TPC guys just brought several new versions of this workloads, which are often used or not used, reworked on, I don't know. Interesting is also this TPCH workload, because that is an example for a more analytic-based approach doing benchmarks, and that will be important later for HammerDB. So, and there are several other replacements. There's a history on the website. You can read it, and it's interesting, but a little bit dry stuff, right? So, and the problem is that TPC is a really company vendor-driven thing, and some reports are expensive. So what I see in TPC is actually, it's not that relevant anymore, but the ideas of the standardized workloads are still a thing. So if you see pgbench is using this, HammerDB is using this, so you can always tell, okay, that is something like TPCC, and everyone will know what exactly it is, right? And everyone will recognize this as something several tools are using, right? So that is the important part. So, and it's always possible for fair use. Fair use it's called, like for research, you can always dig around and use the reports of TPC if you are interested in it. But that is about where this TPC came from. That is basically an organization, non-profit, but sponsored by a lot of interesting large companies. You can imagine to what that could lead, right? And yeah, that thing. There are other tools what I, let's say, at least had a look on when I started my journey. There was Sysbench. You can do a lot of database stuff also with Sysbench. There's this old TP bench, which is renamed now to Bench Base. Then it's PG Bench Tools, which will also be renamed to PG Bend. And there's one Yahoo, also kind of a tooling. I just read shortly between those examples, but everything was not, in my opinion, not useful for me or not as established like PG Bench or later on HammerDB. So, but just give you an impression, there are other tools. Maybe there's some tool which is better for you. You feel free to test it. Everything is open source here, I guess, by Yahoo. I guess it's open source, yeah. At least you can get the code from GitHub, let's say. And maybe you find something better. But for me, it was not the case. So my next step would be to jump on HammerDB. HammerDB, not only the name is cooler than pgbench, but it's also kind of a very established tooling for benchmarking for databases at all. So it's, I always make this slide, you know, for Postgres, and all my tools are showing, I want to show it that I really like the idea of seeing the license, the first version 1 and the actual version and the code. It was, for instance, HammerDB is tickle-based. And most importantly, I want to show the status of GitHub to see that is a tool which actually is still maintained, if you see the contributions, right? So if you see the green bars on the right side not happening anymore, I would be curious, right? So just my usual standard slide for any tool I'm showing here. So Postgres. HammerDB is a tool which is able, and now that is a cool point here, not only doing benchmarks for Postgres, but also for Oracle, SQL Server, DB2, even DB2, yes, MySQL and MariaDB. So that is a good thing. It's on all platforms, like I said, it's tickle-based. There's a GUI. I don't like the GUI, to be honest, but at least you can have some fancy graphs if you want so. And it brings two basic workloads. And now you see the key point why I want to jump on HammerDB now as a next step. So tproc-C is basically a TPC C-based approach, which is just a further development of TCP/B, so that is comparable with the pgbench approach. You can see the schema here if it's important, but it doesn't matter actually. And there's also a TPC-H approach, which is called here tproc-H. So it's just renaming. I don't know if there's any license thing going on, but at least that is based on TPC-H, which represents more analytic-based workload, which would be important for me for other stuff later. So at least I have two different workloads here. And I can start comparison between MySQL, which is also an offering from Aiven, and Postgres. And also for analytics, that AlloyDB, what we also have, but more on that later. So, and the idea is almost the same like pgbench. So here, what we have seen before with pgbench, which we do with scaling, is here now called warehouses. So just increasing the amount of warehouses is just increasing the amount of data. And you have this virtual users that is basically the same like the clients in pgbench. So the approach is similar. So you see also, if you look at the, I don't know if it's readable, if you see in the schemas, you see the factors of the table. So for instance, the stock table on the TPC C base is when you are increasing the warehouses, each new warehouse is 100K rows more. So if you get an impression how large that is. I'm not sure about this number, 100 warehouses are around 10 megabytes. I'm not sure, I have to recheck. That number I have stolen, to be honest. And I will check this and will change that in the slides. I think it's larger, way larger. But at least you will get an impression that if you scale up the warehouses, the database will grow quite fast then, right? And yeah, that's basically it. So the installation of HammerDB is quite easy as well. So just download it, extract it, and then you have everything you need. So no installation, that's it. So it's open source, of course, so you can just use it, copy it, and everything. It's for Windows, it's for Linux. You have the GUI there. Everything what you can do in the GUI, you can have also kind of a command line, which I will show you later. Feel free to start with the GUI. I think the GUI is terrible, but at least it's easy to jump on it, right? So the command line is, if you just extract it, I will show it later, I will just go through it shortly. You will see there's a HammerDB CLI, and then so you know you can do everything. Everything what I'm showing here, you can also kind of package together, right? So you don't have to type in every command. You can also kind of script everything together, like with Tickle and everything, so that's easy. So at first you should do a library check. So that's the first thing you should ever do all the time, because you want to see that, right? You know, all other databases, you will get a lot of errors, like Oracle is not available whatsoever. The important part is that you will find your Oracle libraries. If not, then you have to check. If not, you should install Postgres, if not always already happened. And if not, you should check your path, variables, and everything. And then you can start doing stuff with HammerDB. So the first approach is to select your database of choice. Now you can, of course, do MySQL, Oracle, and everything. First start DB set, DB PG, Postgres. There's a help. If you type in help, you get a help. So you don't need to remember all that stuff, but you will get a point how it works later. And you should set the workload. In this case, TPC-C. And then you can make print dict, and you will get an output about stuff what is per default configured. You can change everything here, but you get an impression what kind of stuff you can configure for this particular workload. So the good thing is here you can just prepare everything and you can run all the time, not like pgbench where you have to specify the connection parameters all the time. You create kind of a session all the time, so it's just prepared and you can just run. That's fine with HammerDB. So for the automatization aspect, that is way better. And then here's an example how you can configure it is with the command dset. So connection, for instance, port, the number of virtual users, not client anymore, the amount of warehouses, and so on. So that is basically what you can do. And if you set this and you go back here and making a print dict again, you will see the changes reflecting there, of course. And then you will build a schema that is the counterpart of pgbench minus I. It's taking a bit longer, even with one warehouse, as pgbench. So there's initial workload is taking a lot more time. I will show it later. And then you can do a VU run, and that's it. Then you have a benchmark. Now you get several metrics here. Now we have not only here's transaction per minute, TPM, and the new order per minute. So that is the result explained. So the transaction per minute and the new order per minute are the both metrics you get here also. So at the moment, the new order per minute is better to compare between different database engines, for instance, MySQL and Postgres. Everything else with transaction per minute, you already have seen, that's the same. So you can use this as well for to compare the database engines, but the better approach is the new order one. So, but let's show you some real-life examples. It's better, I guess. So, here you see the result. No, here, and actually the amount of transaction per second. The result, but within the bench run I did before, just to show you that I'm not lying here. So, and okay. I have a little dirty little helper here to get to. Basically, I'm firing up my HammerDB. You see here, it's just downloaded and extracted, nothing more. And pgbench, it's a little bit misleading. In pgbench, is actually my Postgres instance. It's not PG bench, it's PG underscore. Yeah, I don't, you know, it's just the instance, so don't wonder here. I know it's stupid, yeah. And here's a HammerDB CLI. So now I have a CLI, right? It's basically a predefined CLI, and now we did the library check. And now that is what I mentioned. You get a lot of errors, so no MySQL, no Oracle, no whatsoever, but that's the stuff here, right? That is what we want to see, right? Checking database library for Postgres, and if not, it's mostly it's missing some path variables or something like this. So that's the thing. So it's just searching for the PGCTL actually. And yes, then I will switch to the Postgres setting. That is just db set db pg. So that's it. Then I will predefine the workload, db set benchmark tpc c. So that's the preparation you have to do. And now you can predict, you will get all the parameters like the host, the port, SSL mode, all this kind of stuff. And there are a lot of configuration things, basically what you can think of, the ramp-up time, duration, whatsoever, vacuum, and a lot of things are similar to PG Bench, not everything. There's also kind of stuff with Citus going on here. So I haven't tested it yet, but there's a talk about this from the Microsoft colleague somewhere. I've seen this. I haven't looked this. You can define table space, and you know that is basically the username, password, and connection stuff, and some configuration parts. So, and you can set it with with dset. Like I just change it for once. Dset connection, or let's say just PG num for U, the virtual users, to 2. What did I wrong? Number of arguments. TPC, yeah, you have to predefine the TPCC before misleading. So now you can change it from 1 to 2. I will go back to 1 to make my example quickly. So you can play around now with this, right? And now we create a schema, build schema. So now it's creating the schema on the same database like where we tested the PG Bench before. That will take a while, not a while, it's more than PG Bench. And you will probably see also kind of traffic here, I guess. Here's only one session. I think the amount of virtual users are reflecting also the creation of the build schema. So if you create 5 users, it will also do that in parallel. And yeah. And that's all a quick start, right? So to give you a first impression how to work with HammerDB, so there's a lot of more stuff you can do. I won't show you the GUI, you can check it out for yourself. And and you can also install it on Windows. If you have Windows stations, it's also not a problem. And I think Mac as well. And almost everywhere I have seen people doing benchmarks, there's serious benchmarks. Almost everyone is jumping to HammerDB for some time. So it's good to know that HammerDB is not that difficult to use. That's almost the same like PG Bench, and yeah, it's finished. So and now we can do the VU run, and now we, there's should be a session coming on. There's a ramp up time for 2 minutes. Yeah, we have disabled it. We could have disabled it. Oh yeah, okay. Let's talk. So now it will run and will get you the result. So that's basically it. So it's quite easy. Let me just switch to the slides because of the timing. So yeah, that is basically the result. I have explained already to you TPM and new orders per minute honestly, the new order per minute approach, comparing between MySQL and everything, I didn't use it yet, but I will. So that is just the beginning. And my initial task, when we think about my initial task, what I had, I started with pgbench to fulfill the exercise I started before, right? What I did is just create a set of t-shirt sizes. So I selected 4 significant sizes of the offering of Aiven, because I cannot do everything. It's insane, right? I started with the hyperscalers, the 4 hyperscalers. Yes, I think Oracle, I called it also a hyperscaler. And I did a long run, 60-minute, and 5 minutes, and a short one. I want to see, is it something which is different when you let it run longer or shorter in a matter of transactions per second. That was my interesting approach. Then I have created a compute instance, just a virtual machine, for each cloud vendor on the same region with databases to make sure that I don't have any network trouble or latency somewhere in between, so that every test was going against in the same availability zone and everything. So the sizing of the VM is not that important. It was not a small one, but at least one who could say, okay, that won't affect the benchmark at all. It's just a client forcing a query, so it's good. If you're running a lot of clients, then you have you should not take a 1-core machine, of course, right? I selected all databases with default parameters. That will come up next to change a little bit, tweak a little bit. Then I created a script based on what you have seen and just let it run. And it cost a lot, right? So I've seen the costs, and it was my company was prepared, but it was kind of a significant amount of consumption what I did. But it was requested, right? And what I also did is I wanted to prevent abnormalities. So what I did is every test was done 3 times on several times, day or night, and something to just see, is there anything what is different? But the difference between the results from the transaction per second was almost less than few percent, maybe. So it was kind of a noisy thing, right? It was fine. So I just make an average, and that's it. And I selected a rough scaling. So our t-shirt sizes are called 4, 16, 32, 64. I choose the same amount of clients. So for 64, I have chosen 64 clients, and I choose the scaling like roughly 500, 1,500, and so on, right? So you can see it here, just to get an impression how I started my approach. And it's interesting. I just give you some results, which just to give, it's not my overall result, but a few impressions I will give you, not advertising Aiven at all. It's not just like to see what I found out. If you look here, that is the 4 hyperscalers and our default approach. So you see here a significant difference between the performance between the same size of the database. For instance, between AWS and Azure and GCP, which are performing way better. And that is the thing, you always have to check, that is my next step, to check what kind of compute instance is selected per default. So that's a huge difference, right? Maybe different processors whatsoever. But I just selected the default value, so no questions asked, right? But it's really interesting. From Oracle Cloud, I don't want to mention, right? It's true numbers. I don't, it's no advertising, no all, it's just dry numbers. Also interesting, that was kind of disappointing, I just selected the same cloud vendor, the same sizes, same stations, but the different, I'm way faster, yeah. Postgres versions. And even when it's not that much, from 15 to 17, it goes a little bit slower. You see it here? I would expect different, but maybe it's about of default parameters or whatsoever. That is what I want to figure out later. It's not worth mentioning, see, it's quite similar, but it's interesting, right? If someone asks, well, why is my Postgres 17 a little bit slower than my 15, that's a question which I have to answer, right? And That both diagrams are just an example of what kind of funny things you will see if you're just making a structured overall benchmarking in this large field, right? So, and that's only 2 examples. I have seen different stuff. So, but I cannot share everything yet because we haven't released anything yet. I will create something with a blog post or something like this. And so, what is the next step? So, I'm 45 minutes, so that is my plan. So, a lot of more research. So that I know that is just my start. So, my idea was to bring you an impression what journey I did now so far, and I'm in a rabbit hole now. So I will continue. I will spend way more time for this. I will do a lot of more research. I want to see more long-term results. I will consolidate everything, and there will be an Aiven blog post. There is something similar, which is very old, and that was also the motivation for this, to replace it sometime. And I will give you an impression about everything. I will switch to HammerDB because I need analytic workload. We also have in our offerings, and I'm not so proud of it, we have AlloyDB Omni in our offering to give the Google Cloud customers the chance to making multi-cloud for AlloyDB. So, and you know, when the marketing team from Google came in and say, AlloyDB is Postgres on steroids, that's a quote. And I did my first test. That are tests I'm not sharing right now, but I did the first test, and turns out no, right? So at least for the TPC-B approach, so regular workload is not even faster. It's significantly slower. That I can tell you, but and now I want to see maybe because AlloyDB does a lot of advertising about analytics. Now I want to test this. We'll see. I haven't done it yet, but I'm really excited to do it. I will making more detailed questionings about the compute instance in use. So I will add this information to my benchmarking. So to see maybe, I also want to try several compute instances as well. Yes, more work, but it's important. You have seen the differences between the hyperscalers. That doesn't make sense, right? And I also want to play around with a few significant parameters, like you know, what will happen in the same benchmark when I increase a shared buffer or the work mem and so on to see what's going on there. And I want to do more graphics about this, right? And want to share it actually. And you know, I'm not a developer, but I need to do better scripting and better automatism in this. So I'm improving. And there's another little thing in Germany. There's a company called BenchEnd. They are doing commercial publishing benchmarks. And I had talked to them already, and there is an idea to work a little bit together and sharing stuff and so on. We'll see how it goes. So the journey continues, right? So I don't know how to get rid of the bar. Okay, you see that is just the tip of the iceberg, right? What I have found here. So there will be several other talks. So like Peter Jackson, he likes trilogies. So maybe I will do different talks now. Maybe the desolation of the hyperscalers. I found it funny. I will go on with this, and my idea is to share it with conference visitors and so on. So I think benchmarking is an underestimated and interesting topic. It is a lot of work, but I think there are not many talks or many projects out there going so much into details, so I want to fill this gap somehow and making it open to everyone. So a lot of work. So some takeaways: choose wisely the tools, think about your effort and your goals. Always think about Udo. You know, you see my teacher from the past. Measuring is always challenging, and you need to have context and comparison structure. That is a key point. Not just measure something and don't know why and whatever, right? So clarify your metrics, what you want to do, before you start, right? That's important. I didn't do this, right? So I was just trying out, and that was a trap. And do a lot of reproductions. That is important. So test it and make it reproductional, so that you can be able to repeat it and see how it behaves, if the numbers are really making sense and everything. Well, that's it. I hope it was useful for you. Again, there will be follow-ups. If you have questions, I don't know if you have time. I will be here around. You can always ping me or ask me outside. And thanks for your attention.
Well done.
So here's the result, by the way, if you're interested, what happened there. So
Yeah.
just for completion.
I have a small question about your PG bench benchmarking different versions. If you are using the same version of PG bench as the version of Postgres.
I was thinking there is it could be a difference. I did a mistakenly run with a version 15 benchmark to 16 and 17, and I recognized this, and I think, oh damn, I have to repeat it now with the same version, but it turned out the results were insignificant the same. So I don't know if you go with a version 7 to 16 or I don't know, but at least for the last 3 versions, I cannot tell you that there's any difference because it's the same workload. PG Bench is not doing any version-specific stuff. So, but in my final test, I did make sure that it's the same version.
Okay. In our experience, when we tested version 15 and 16 with PG Bench 15, the 16 server was slower. When we did the same with PG Bench 16, it was the opposite. So
okay, that's way slower, or what would you think the amount of being slower? How much percent, roundabout?
It was like, I don't know, 10-20%.
Oh, okay, that I didn't recognize. So again, I tested it and I did run the test again. It was kind of the noisy part, right? That less than 5% max, right?
Okay, thank you.
Maybe I would add to this. We were using, not sure what was your scaling parameter. We used to scale like 50 or 90.
The reason for this? Why I chose the scaling part?
I'm just adding to my colleague that I want to provide additional information that the scaling was 50 to 90 to test on bigger amount of data.
Okay.
So I don't know what was your scale parameter.
You have seen the scaling part. It was up to 4,000.
4,000.
So,
okay.
Yeah.
You mentioned that it's cost amount of money, the testing. Do you have some comparison against which hyperscaler was the cheapest and which was the more expensive to run this benchmark? Because it's price per transaction, something like that, some graph.
That I will prepare, but I didn't do the calculation because what I do this is, of course, for Aiven, not for when I'm using Aurora and everything. I didn't share any Aurora results here, right? Because I want to be politically correct. And you can ask me outside, but for Aiven, I will do this in my final blog post to show you what kind of hyperscalers will provide with our offerings the amount of money per transaction. That is a target, but that is right. I have no numbers, right?
Okay, thanks.
What I mentioned was kind of the whole benchmark effort was kind of a lot of money because of consumption. No Oracle questions, please.
Yeah, thank you for the talk. You said you are using Postgres default parameters. Were they Postgres?
No, stop. Not Postgres defaults, Aiven defaults. Aiven have for the larger plans, they have kind of shared buffers like 25% of the RAM and so on, right? The best practice part. So it's not like that I have a 64-core machine with 120 megabytes shared buffer, for instance, right? So I use the defaults from the offerings, not from Postgres at all.
Defaults from each cloud offering.
Yeah, our offering, and also when I created, let's say, an RDS instance for Postgres, I didn't change any parameter, right? So.
Yeah. So when we did benchmarking, some of the parameters like JIT and few other parameters related to parallel workers, they were influencing test results significantly. So because we did not use them in OLTP, we found Postgres 16, 17 to be much better performing on similar hardware.
Yeah, I will figure it out. No one? Then thanks again and have a nice afternoon.